Get ready to embark on an epic game development journey and recreate one of the most popular games ever created, Space Invaders. With just a few hours of your time, you'll be able to create your very own, fully functional and engaging Space Invaders game using Python and Pygame. Join me as I take you step by step through the process, from setting up the game loop to creating the spaceship and the aliens, to implementing movement, collision detection and scoring. You are going to learn invaluable game development concepts and techniques along the way, and by the end of this tutorial, you are going to have a polished and exciting Space Invaders game that you can proudly share with the world. To fully benefit from this Space Invaders game tutorial, it is recommended that you have a basic understanding of Python programming. If you are new to Python, consider watching my Python for Absolute Beginners course first, which can be found in the video description or in this card. Additionally, if you are new to game development with Pygame, I suggest starting with our Pong, Snake and Tetris game tutorials, also linked in the video description, to make the learning process smoother. Don't worry if you are not yet an expert in Python or Pygame. This tutorial will provide valuable insights and help you learn a lot. As Lao Tse once said, the journey of 1,000 miles begins with a single step. So, let's take that first step towards creating our own Space Invaders game and see where this journey takes us. Space Invaders may seem complex and challenging to develop, but fear not, we will take a divide and conquer approach to make it more manageable. In this tutorial, we will break the development process down into 12 steps, tackling each one individually and building upon what we have accomplished in previous steps. With this approach, you'll be well on your way to creating your own Space Invaders game in no time. So let's get started to see how we can conquer this challenging project one step at a time. Before we dive into this exciting game development journey, I would like to mention that your support means the world to me. If you find my work useful, there are a couple of ways you can help the channel grow. One way is to become a member of the channel by clicking the join button. Depending on the monthly fee you choose, you will unlock some fantastic perks, like influencing the selection of the next projects I work on and receiving exclusive updates. Not only does this support me financially, but it also helps me focus on creating the most useful content possible for you, without the constant pressure of chasing views and ad revenue. If you can support the channel financially, that's perfectly fine. You can still show your support by simply liking the video if you find it helpful and subscribing to the channel. By doing this, you'll be the first to know when I release new tutorials like this one. Your support means everything. And now, let's jump right into the tutorial. The first step is to install Pygame. Pygame is a Python library used to create games and multimedia applications. In this tutorial, we will be using the Pygame Community Edition, a fork of the original Pygame library that is updated constantly with new features and bug fixes. However, you can also use the standard Pygame library if you prefer, as the code we will be using is exactly the same. To install the Pygame CE library, all we have to do is to open a terminal window and type the following command: pip install pygame-ce. With the Pygame library installed, we can now verify that it is working correctly by running a simple test script. To do this, we create a new folder, let's call it Space Invaders, and then we create a new Python file in it, and we name it main.py. Now we can open this file with our favorite editor. I will be using Sublime Text in this tutorial. Inside the file, we have to import Pygame by typing import Pygame. Next, we have to run the program to see if Pygame is installed correctly. In Sublime Text, simply press Ctrl+P to run the program. If you see the message Pygame-ce, our installation is working fine and we have successfully completed step number 1. That was easy, wasn't it? We are one step closer to our goal of building a fully functional Space Invaders game. Let's move on to step number 2. The next step in building our Space Invaders game is to create a blank screen and set up the game loop. Before we start, it is important to understand the structure of a game. Every game consists of two parts: the part where we define our variables and game objects, such as the spaceship, the obstacles, the aliens, and the user interface, and the game loop, which is responsible for updating the positions of the game objects and checking for collisions. The game loop is like the heartbeat of the game, running repeatedly until the game is closed. In each iteration of the game loop, we will draw the game objects in their new positions and check for collisions, all happening so fast that it appears as a continuous movement. Now, let's create a blank screen and the game loop. First of all, we need to initialize Pygame, so we type pygame.init. Then we create a display surface. A display surface is like a black canvas where we can draw our game objects. We need to specify the width and the height of the display surface. I'm going to use a size of 750 by 700 pixels for now. We will change that later. Let's create the display surface. First, let's create two variables to hold the screen width and screen height for our game. Screen width is equal to 750 and screen height is equal to 700. Now we can create the display surface. Screen is equal to pygame.display.setMode parentheses, and again parentheses, we need a tuple, screen width, comma, screen height. This line of code creates a display surface object named screen. The setMode method takes a tuple as an argument. The first value is the width and the second value is the height of the display surface, our canvas. In simpler terms, we just created the game window, and to draw on it, we use a coordinate system similar to the one taught in high school. Each point on this window has its unique x and y values. The coordinate system used in computer graphics differs from the standard Cartesian coordinate system taught in high school. In computer graphics, the origin of the display is located at the top left corner, with 0, 0 being at the top left. In contrast, the standard Cartesian coordinate system starts from the bottom left corner, with 0, 0 being the origin. In this system, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move up. However, in the top left corner coordinate system used in computer graphics, the x-coordinate increases as we move to the right, and the y-coordinate increases as we move down. This means that a point at 10, 10 will be located 10 units to the right and 10 units down from the origin. We will be using the top left corner coordinate system in our Space Invaders game. That's why it is important to understand the difference between these two coordinate systems. Now that we have created the screen, we need to give it a title. We can do that by using the setCaption function. Pygame.display.setCaption parentheses quotes Python space invaders. Next, we create a clock object like this. Clock is equal to pygame.time.clock. Be careful, we need a capital C here. We need this clock object to control the frame rate of the game, how fast the game will run. Don't worry about this line of code now, we will get back to it in a minute. The basic setup of the game is now complete. Let's now work on the game loop. The game loop consists of three parts. First, event handling. First, we need to check for any events that occur in the game, such as quitting the game, a key pressed on the keyboard, etc. This is done using the Pygame event handling system. 2. Updating positions. Next, we update the positions of all the game objects, like the spaceship, based on the events we detected in step number 1. Drawing objects. Finally, we draw all the game objects in their new positions on the screen. This step uses the Pygame graphics functions to render the objects in the display. By following these three steps, we can create a dynamic and interactive game that responds to user inputs and updates its state accordingly. We start the game loop with a while loop like this. while true, colon. The while loop is an essential part of our Space Invaders game. It runs continuously until we close the game. At each iteration of the loop, we perform 3 key steps: checking for events, updating position of the game objects, and drawing the game objects in their new positions. It is important to note that before running the game, we need to ensure that the code inside the while loop has been fully written. If we run the code at this point, the while loop will run indefinitely, since we have not defined a way to stop its execution. So, in the next step, we will add the necessary code to stop the while loop. For event in, pygame.event.get parentheses and colon. This line of code gets all the events that Pygame recognizes and happened since the last time the while loop ran and puts them in a list. Then we loop through the list of events and check if any of the events is the quit event. The quit event is when we click on the close button of the window. If the event is the quit event, we break out of the while loop. If event.type equals pygame.quit, pygame.quit, and then we have to close the program completely with the command sys.exit. This function is part of the sys module, so we have to import it like this. In the first line of the code, after importing pygame, we type sys. That's it. Now we have defined a way to exit the game, but we need a couple more lines of code before running our game for the first time. We have to update the screen with this line of code, pygame.display.update. This line of code takes all the changes we made in the game objects and draw a picture from them. Since we haven't created any game objects yet, this line just draws a black screen. Remember the clock object we created at the beginning? We need to use it now. We have to tell the clock object how fast the game should run. We do that by using the tick method. The tick method takes an integer as an argument, and that integer is the number of frames per second that we want. I am going to use 60 frames per second. Clock.tick60. That's it. This means that the while loop and all the code inside it will run 60 times every second. If we didn't set a frame rate, the game would run as fast as the computer can handle, which could lead to inconsistencies in the game speed. By setting the frame rate, we make sure that the game runs smoothly and at the same speed for all players. Now that the game loop is complete, we can run the game for the first time. If we run the game at this point, we won't see anything inside the game window because we haven't drawn anything yet. But the important thing is that we can see the game window with the title and the dimensions we defined, and that we can reliably close the game by clicking on this X icon here. Beautiful! The game window is black. Let's make it a dark gray color. Pygame provides several built-in colors, but we will be defining our own colors for this game. In Pygame, colors are represented as a tuple of 3 values, each value representing the amount of red, green, and blue in the color. The values for each component range from 0 to 255, where 0 represents the absence of the color and 255 represents the full intensity of the color. For example, to create a red color, we will create a tuple with the following values. Red is equal to, parentheses, 255, 0, 0. These values represent the red, green, and blue components respectively. So, to create a gray color, we will create a tuple like this. Gray is equal to, parentheses, 29, 29, 27. Now, let's paint the game screen gray. Inside the game loop, before updating the screen, we call the fill method of the screen object like this. Screen.fill, parentheses, gray. The fill method just fills the display surface we have created, our canvas, with the color we define. In this case, gray. If we run the game now, we can see the game window is now gray. Beautiful! We just completed a very basic game loop. so we can remove step number 2 from our list. We have made progress. Now let's work on step number 3. To prepare for writing code, it is important to take a step back and think through the game logic thoroughly. In Space Invaders, we have several game items, including a player-controlled spaceship, descending alien invaders, and defensive obstacles. The goal is to protect the spaceship from being destroyed by the alien invaders while shooting them down to earn points. As the game progresses, the aliens descend closer, increasing the challenge. From time to time, a mystery ship appears, and the player can hit it to earn more points. Alongside the gameplay, there are also UI items, such as displaying the player's score, lives, and the all-important high score. Mastering the coordination between player movement, shooting, and defending against the alien onslaught is the key to success in this classic arcade game. First, let's create a player-controlled spaceship. Let's go back to our code. We are going to use object-oriented programming to help us organize our code. We will create a spaceship class. Let's create this class in a separate window. I press Ctrl+N to create a new file and then Ctrl+S to save it as spaceship.py. Creating a spaceship class will help us define how the player-controlled spaceship behaves in our game. Think of it as giving our spaceship a set of superpowers. We will control how it moves, how it shoots, and even how it looks on the screen. Here's something cool. We are going to introduce a new tool called the Sprite class from Pygame. This will make our game-making adventure even more fun and manageable. The Sprite class in Pygame is like a super handy tool when creating your spaceship or any game character. It helps keep everything organized and makes your code less messy. Imagine it's like having a special container for your character. This container holds everything: how your character looks, where it is on the screen, and how it behaves. Plus, it's really smart when it comes to checking if your character bumps into something or shoots an enemy. Think of it as putting all your game pieces in one box, so you don't lose them. You can even put similar pieces together in different boxes. For example, you can have one box for all your spaceship's bullets. It's like magic because it helps your game run smoothly and makes it easier to create cool stuff like aliens and more. So using the Sprite class is like a secret weapon for game creators. But we are not just going to talk about the Sprite class, we are going to see it in action right away. This way you will understand exactly how it works, and trust me, it's going to make creating your game a whole lot cooler and easier. So back in our code. In our spaceship.py file we type import pygame to import the pygame module. Then we type class spaceship parenthesis pygame.sprite.sprite : our spaceship class will be a child of the sprite class. Now let's create the init method which will initialize the spaceship object. Def init parenthesis self : Next we utilize this line of code to indicate that our spaceship class should inherit all the attributes and methods of the sprite class. Super parenthesis dot init parenthesis. This statement initializes our spaceship object by calling the constructor of the parent class, the sprite. Now let's initialize two important attributes inherited from the sprite class: self.image and self.rect. To set the sprite's visual appearance, we assign an image to the self.image attribute. This image represents how our sprite will look in the game. I have placed all the images that we're going to use in this game in a folder named graphics inside our game folder. You can download all the files from the GitHub repository linked in the video description. So let's load an image from the graphics folder. Self.image is equal to pygame.image.load parenthesis quotes graphics / spaceship.png. In this line, we load an image file named spaceship.png from the graphics directory, assuming it's in the same directory as your game script. This image will serve as the visual representation of our spaceship in the game. We use the pygame.image.load function to load the image, and then we assign it to the self.image attribute. After loading the image, we create a rectangular region, a rect object, to define the position and the size of our spaceship within the game world. Self.rect is equal to self.image.getRect, parentheses. This part of the code retrieves the default rectangle for the loaded image. This rectangle is initially aligned with the top left corner of the image and has a size equal to the dimensions of the image. Now we have to specify how we want to position the spaceship on the screen. Let's enter mid-bottom is equal to parentheses 100, 100 here to test it out. Mid-bottom indicates that we want to position the rectangle so that the middle of the bottom edge of the rectangle is at the coordinates 100, 100 on the game screen. This is a common way to position sprites, as it ensures that the sprite's bottom center aligns with the specified coordinates. So in summary, those two lines of code load the spaceship image and create a rectangle that defines the position and the size of the spaceship on the game screen, making it ready to be displayed and interacted with in the game world. Now we are ready to see our spaceship for the first time. Let's go back to the main.py file. Here is a quick shortcut. You can press Alt+1 and Sublime Text will get you back to the first open tab of your project. First, let's import the spaceship class. From spaceship, import spaceship. With the class imported, we can now create a spaceship object. Spaceship is equal to spaceship. However, before we can display our spaceship on the screen, there is one last important step we must follow. We are going to create a group and add our spaceship to it. But what exactly is a group and why do we need it? A group in Pygame is a container that helps manage and efficiently render multiple sprite objects. It provides functions for handling collision detection, updates, and rendering for all the sprites within it. Now let's put our plan into action. To manage our spaceship, we will create a dedicated group for it. Spaceship group is equal to pygame.sprite.groupSingle, parentheses. Here we have instantiated a groupSingle object, tailor-made for holding a single sprite, which in our case is the spaceship. To integrate the spaceship into this group, we simply add it like so. Spaceship group.add parentheses spaceship. Now we are all set to render our spaceship group, which includes our spaceship sprite. To achieve this, we can make use of the draw method provided by the groupSingle object. In our main loop, we simply type spaceship group.draw parentheses screen. This tells Pygame to draw the sprites contained within the spaceship group onto the specified surface, which in our case is the screen. When we run the game once more, we will finally see our spaceship for the first time. It is a significant step forward in our game development progress. When we use the draw method for our sprite, it appears on the screen where we told it to be. We originally said we want our spaceship's bottom middle part to be at position 100, 100. That's why the spaceship starts at the top left corner of the screen. But what if we want to start in the middle of the very bottom of the screen? To make this happen, we need to provide our spaceship class with information about the size of the game window, which it currently doesn't have. It should know both the screen's width and height. Now let's return to our spaceship class by pressing Alt+2. In our init method, we will add two new arguments, screen width and screen height, like this. Let's also create two attributes to hold the screen width and screen height, as we are going to need it again in the future. Self.screenWidth is equal to screen width and self.screenHeight is equal to screen height. Then we will update this line of code to position the spaceship in the middle of the screen at the bottom. What's the screen position for this point? It's quite simple. For the x-coordinate, it's screen width divided by 2, and for the y-coordinate, it's screen height. Here's why. When we want to center something horizontally on the screen, we put it at half of the screen's width. And to place it at the bottom, we set the y-coordinate to the screen's full height. So, screen width over 2 is the center of the screen horizontally, and screen height is the bottom of the screen. Now, let's return to the main.py file to test our changes. We will make a small adjustment to our code. When creating a spaceship object, it now needs two additional pieces of information, the screen width and screen height. Let's provide that information using screen width and screen height. With this done, we can run the game once again, and you will notice that our spaceship is now perfectly centered at the bottom of the screen. Cool. Now let's make our spaceship respond to the player's commands and move accordingly. To do this, we will need to make changes in our spaceship class. So let's head back to the spaceship.py file. Inside our spaceship class, we will create a new method called getUserInput. This method will handle player input to move the spaceship. Def getUserInput parenthesis self. First, we're going to get a list of all the keys that are currently pressed. That's just one line of code. Keys is equal to pygame.key.getPressed parenthesis. Now we need to check if the left or the right arrow keys are pressed. First, let's check if the right arrow key on the keyboard is pressed. If keys brackets pygame.k_right colon. Here we check the list of pressed keys to see if the user is pressing the right arrow key on the keyboard. Now we need to move the spaceship to the right. To do this, all we have to do is to move the rect attribute of the spaceship class to the right by a certain amount of pixels. Let's call this amount speed. To move the rect on the x-axis, we just have to change the value of its x attribute. self.rect.x plus equals self.speed. But we haven't defined the speed attribute in the spaceship class yet, so let's create it. Self.speed is equal 6. Now let's do the same thing if the player presses the left arrow key, but this time we decrease the x-coordinate. If keys brackets pygame.kleft colon self.rect.x minus equal self.speed. That's all we need for the basic movement. Now let's create an update method that will be called on every frame to execute this new logic. Def update parenthesis self. For now, all we have to do is to call the getUserInput method, self.getUserInput. Now let's navigate back to the main.py file and call the update method we just created. We can call the update method of the spaceship class itself, or we can call the update method of the spaceship group that contains the spaceship sprite. In the game loop, before the draw method here, let's call the update method of the spaceship group, which will call the update method of the spaceship object automatically. Let's also add a comment here. Updating spaceship group.update. Now let's run the game. As you can see, the game works. We can now control our spaceship to the left or to the right. But there is a small problem. We don't constrain the movement of the spaceship so it can move outside of the game window. Let's fix it. Let's go back to our spaceship class and create a new method. Def constrain movement parenthesis self colon. Our goal is to limit the spaceship's movement within the game window, and achieving this is quite easy. To begin, we will focus on constraining the spaceship movement towards the right edge of the window. To do this, we will retrieve the x-coordinate of the right edge of our spaceship's bounding rectangle, the rect. If self.rect.right greater than self.screenWidth colon. If the spaceship has moved beyond the boundaries of the game window, our task is to reposition it inside the window. Self.rect.right is equal to self.screenWidth. We apply a similar approach to the left edge of the window. If self.rect.left less than 0, self.rect.left is equal to 0. Before we run the game again, there is one final step. We need to include a call to this method within the update method of our class. Since the update method runs in every frame, it's the perfect place to ensure the spaceship's movement stays within bounds. After checking for user input inside the update method, we will apply the constraints to the spaceship movement. Self.constraintMovement. Now let's go to the main.py file, Alt+1, and run the game one more time. Perfect! As you can see, the game works, and the movement of the spaceship is now constrained inside the game window. Beautiful! We have successfully finished step number 3, where we created the player-controlled spaceship. Now let's dive into step number 4, where we will work on the lasers. In our game, both the spaceship and the aliens have the ability to shoot lasers. To keep things simple, we will represent the laser beams as bright yellow rectangles. When the player presses the spacebar key, a laser beam will be fired from the spaceship and move upwards. Let's jump right into implementing this exciting feature. We are about to create a laser class that will define how laser beams behave in our game. What's cool is that we will use this same class for both the lasers fired from the player's spaceship and the lasers that the aliens shoot. One class, double the laser action. Let's start by creating a new file. Ctrl+N to create a new file and Ctrl+S to save it as laser.py. Now again we have to import by game. Import by game. Now for the exciting part, let's build our laser class. It will inherit from the sprite class, and this inheritance will help us keep all the lasers organized and handle collisions easily. Here's the initial setup. Class laser parenthesis pygame.sprite.sprite:. Now let's create the init method. Def init parenthesis self : super parenthesis dot init parenthesis. Ready to give those lasers some power. To make our lasers visible, we will need both an image and a rect, since we are inheriting from the sprite class. There are two ways we can do this. We can either load an image from our computer's files, or we can create a simple image on the fly, since lasers can be represented as basic rectangles. I'll choose the second option to learn something new. Let's create a yellow rectangle to represent the laser. Self.image is equal to pygame.surface parenthesis, and now we need a tuple, parenthesis again, 4,15. This line of code creates a small rectangular image to represent our laser in the game, where the width is 4 pixels and the height is 15 pixels. This rectangle will serve as the visual representation of the laser when it's displayed on the screen. The laser surface is now created, but it is empty. Let's fill it with yellow color. Self.image.fill parenthesis, and now we need a color tuple, parenthesis again, 243,216,63. This tuple is just a yellow color. Great, our image is ready. Now we need to define the rect for our laser. Self.rect is equal to self.image.getRect. Now we have to position the laser. We will use its center point to position it, so we type center is equal to position. Positioning our laser is crucial, and we achieve this by providing specific coordinates as an argument to the class. Think of it as setting the starting point for our laser beam. These coordinates determine where the laser will appear on the screen when it's first created. So let's add a position argument to our laser class, position here. The first version of our laser class is ready. Let's now draw a laser beam to test it out. Let's go to the main.py file. First, let's import the laser class. From laser, import laser. Now let's create a laser object. Laser is equal to laser. And now we have to give it a position, a tuple. Let's say 100, 100. The next step is to create a group that will hold all the laser beams that the spaceship will fire. Lasers group is equal to pygame.sprite.group. This time we create a group object and not a group single object because we want it to hold multiple sprites as the spaceship will shoot many laser beams. Now let's add the laser beam we have created to the group. Lasers group.add parenthesis laser. Now all we have to do to draw the laser on the screen is to call the draw method of this group in the game loop. So after we draw the spaceship, let's draw the lasers group. Lasers group.draw parenthesis screen. Now let's run the game one more time. As you can see, a laser beam is now visible on the screen along with our spaceship. Cool! To see one of the advantages of groups in action, let's place another laser beam on the screen. Let's create another laser here. Ctrl plus Shift plus D to duplicate this line. Change the name to laser2 and the position to 100, 200 and add it to the group as well. Laser2 here. That's it. Let's run the game one more time. Beautiful. 2 laser beams are now visible. Very cool. We can draw many objects with just one line of code. The lasers are visible, but they are not moving. Let's make them move. Let's go back to the laser class. We have to add an update method to our class. Def update parenthesis self colon. Moving the laser is easy. We just have to reposition its rect. Since the laser can move only in the y direction, we just have to add or remove some pixels to move it up or down. Let's make the number of pixels to move per frame a class argument, named speed. Self.rect.y minus equals self.speed. Now let's modify the init method like this, speed, and create a speed attribute to the class. Self.speed is equal speed. If we want to move the laser up, we will provide a positive value to the speed argument. If we want to move the laser down, we will provide a negative one. Let's test it out. Back to the main.py file. Let's go to the line where we create the laser beams. We have to add an argument to each call. Let's add 6 to both these lines. Before running the game again, we have to call the update method of the lasers group. So inside the game loop, we type lasers group.update. Now we can run the game one more time. As you can see, both laser beams are now moving upwards. Now let's provide a negative value to the second laser and run the game again. As you can see, one laser beam is now moving downwards. Perfect. We can use the laser class to create the lasers for both the spaceship and the aliens. Very cool. But there is a minor problem with our code so far. When the laser moves out of the game window, it is not visible anymore, but it is still alive in the computer's memory, using precious resources. So it is a good idea to destroy every laser object that moves out of the game window. Back to the laser class to make this small change. So in the update method, we have to check if the laser beam has moved out of the game window in the y-axis. But the laser does not know anything about the game window. We need to provide the game window height in order to be able to check if the laser is inside the game window. So let's add another argument to the game class. Let's add screen height. And let's create a screen height attribute. Self.screenHeight is equal to screen height. Now in the update method, all we have to do is to check if the y-coordinate of the top left corner of the rect is outside of the game window. If self.rect.y greater than self.screenHeight plus 15 or self.rect.y less than 0, colon. We add 15 pixels here because the rectangle is 15 pixels long and we want it to disappear completely from the screen before killing it. Remember, we are checking the top left corner of the rectangle. Now let's print a message. Print, parenthesis, killed. And let's kill the object. Self.kill. When you call the kill method on a sprite object, it effectively removes that sprite from all the groups it belongs to, making it vanish from the game world. Let's go back to the main file and test it out. First, we have to add the screen height argument into these 2 lines of code. Perfect. As you can see, the change works. When the laser beams move out of the game window, they get killed, as we see in the console. Now let's move on. Let's make the spaceship able to shoot lasers. Before doing that, let's remove the 2 laser objects and the laser group. We don't need them anymore. Also, let's remove the call to the update and draw methods of the spaceship lasers group like this. Also, let's remove the laser class import. Lastly, let's go to the laser class and in the update method, let's remove the print statement. We just entered it from testing purposes. Perfect. Now let's go to the spaceship class and add the shooting laser ability. First of all, let's import the laser class. From laser, import laser. Now let's create a new attribute to it, a group, that will contain all the lasers it shoots. Self.lasers group is equal to pygame.sprite.group. Now we need to add a laser to this group each time the player presses the spacebar on the keyboard. So let's go to the getUserInput method and add this feature. We have to check if the spacebar is pressed. If keys brackets pygame.k_space:. Now we need to create a laser object. Laser is equal laser. We need to provide 3 arguments: position, speed, and screen height. The last 2 arguments are easy. Screen height is just self.screenHeight. Let's enter 5 for speed, and now let's calculate where we want to position the laser beam when it is created. We want it to spawn at the center of the spaceship position, so we just have to provide that position to the laser class, self.rect.center. A new laser beam has been created. Let's add it to the lasers group, self.lasersgroup.add Great, now we need to update the position of the laser beam in every frame. We just have to call the update method of the laser class. In the update method, we will add this line of code, self.lasersgroup.update. This line of code will call the update method of all the objects the lasers group contains. Perfect. Now let's go to the main file and draw all the lasers on the screen. In the main loop, after we draw the spaceship, let's draw the lasers group of it. We can access the lasers group like this: spaceship group.sprite.lasersgroup.draw (screen). If we run the game now, we can see it works, but the laser beams appear longer than they should. What happens is that we create multiple lasers, one after another, while we press the spacebar down. We have to add a delay and not allow the player to shoot a laser before a certain amount of time has passed. Let's fix this. Let's go back to the spaceship class. We can use a timer to keep track of when the last laser was fired. Here's how we can do it. We have to introduce 3 more attributes. The first one is the laser_ready attribute. Self.laser_ready is equal to true. We initialize the self.laser_ready attribute to true, indicating that the laser is initially ready to be fired. We introduce the self.laserTime attribute to keep track of how much time has passed since the last shot. This attribute holds a value which corresponds to milliseconds. Self.laserTime is equal to 0. Lastly, we define the self.laserDelay attribute to control the time delay between shots. Self.laserDelay is equal to 300. With the attribute ready, let's create a recharge laser method to be responsible for controlling the firing rate of the laser. Def recharge laser parenthesis self colon. We need to recharge it if it is not already charged. If not, self.laserReady colon. Now we need to get the current time. Current time is equal to pygame.time.getTicks. This line of code retrieves the current time in milliseconds. Next, we need to check if the time now minus the time at which the laser fired is greater than the delayed time. If current time minus self.laserTime greater than or equal to self.laserDelay colon. If it is, we have to set the laserReady attribute to true. Self.laserReady is equal to true. And of course, we have to call this method at every frame. So let's call it inside the update method of our class. Self.laserRecharge. We are almost ready. In the getPlayerInput method, we have to create a new laser beam only if the laser is ready. So we add this check here. And self.laserReady. When we create a laser beam, we have to set the laserReady attribute to false. Self.laserReady is equal to false. And lastly, we have to set the laser time attribute to mark when the laser was fired. Self.laserTime is equal to pygame.time.getTicks. Let's test our game once more. Alt+1 to go back to the main file and Ctrl+B to run the game. Perfect! As you can see, our timer works. The player can now only shoot one laser per 300 milliseconds. It works as expected. Congratulations on making it this far. You have already accomplished a lot, and there is more exciting learning ahead. With this, we just completed step number 4. Let's now work on step number 5. Let's create the obstacles. Before diving into the code, let's take a moment to plan how we will represent the obstacles. In the game, there are 4 protective barriers under which the player's spaceship can hide to avoid alien lasers. While it might seem straightforward to represent them as sprites, there's more to it. The obstacles should display damage when hit, whether by an alien laser or one from the player's spaceship. So, how do we translate this behavior into our code? We will employ a grid-based approach, a technique commonly used in various games. You might remember us using grids in the Snake game and in the Tetris game tutorials. We are going to employ a grid once again in the Space Invaders game. So, rather than representing each obstacle as a single object, we will treat them as a collection of yellow blocks, carefully arranged to create the shape of the obstacle. To do this, we will establish an invisible grid consisting of 13 rows and 23 columns, totaling 299 cells. Each cell can be either empty or it can contain a yellow block of 3 by 3 pixels, a sprite. We will count the rows from the top to the bottom and the columns from left to the right, with the top left cell at row 0 and column 0 being the origin. To represent the grid, we will use a two-dimensional array which can be implemented as a list of lists in Python. To manage this grid, we will assign values to each cell to represent its color and state. For instance, if we want to make a cell yellow, in other words to hold a yellow block, we will set its value to 1. If we want an empty cell, we will assign it a value of 0. This numerical representation simplifies tracking of the color and state of each cell in the grid. As we update the obstacle's visual appearance, we will adjust these values accordingly, making it easier to display the damage they have sustained during the game. So, in order to create an obstacle like this, all we have to do is to create a grid with the following values. If we turn the cells with the value 1 yellow, we get the shape of the obstacle we want. Cool, huh? Now, when a laser hits a cell, we only need to change it back to gray to simulate damage. This approach allows us to dynamically adjust the obstacle's appearance as it takes damage during gameplay. Enough with theory, let's implement it in code. Let's create a new file and save it as obstacle.py. Again, we have to import pygame. Import pygame. Now let's create a block class. The block class will be a sprite, a yellow 3x3 pixels square. We will combine multiple blocks like this one to create the shape of the obstacle we want. Class block parenthesis pygame.sprite.sprite colon. Again, this class will inherit from the sprite class. Let's now create the init method as we did with the other classes as well. Def init parenthesis self colon super parenthesis dot init parenthesis. Again, since we inherit from the sprite class, we need two attributes, an image attribute and a rect attribute. Self.image is equal to and self.rect is equal to. As we said, the block will be a yellow square. Let's create a surface for it. Self.image is equal to pygame.surface parenthesis, and now we need a tuple parenthesis again 3, 3. And now let's give this square a color. We want it to be yellow just like the laser beam. Self.image.fill parenthesis again parenthesis 243, 216,63. Now let's create the rectangle for our yellow block. Just like before, we use self.rect is equal to self.image.getRect parenthesis. Now the important part is positioning this block on the screen. We will place the top left corner of the block at specific x and y coordinates, which will be passed as arguments to the class. Top left is equal to parenthesis x, y. And of course we need to enter x, y here in the init method as the arguments. Great, our block class is ready. Now let's combine a lot of blocks together to create an obstacle. As mentioned earlier, we will utilize a grid to construct our obstacle shapes. In Python, a grid can be represented as a list of lists. Here's what I have prepared. I have created a list consisting of 13 sublists, each containing 23 numbers, either 0 or 1. If you examine it closely, you will notice that if we overlay a yellow square over the ones, we get the exact shape of our obstacles. Pretty neat, right? We will use this list as the foundation for creating our obstacle blocks. Next, let's create an obstacle class. Unlike other classes, this one won't inherit from the sprite class. It will simply serve as a container for multiple blocks. Class obstacle colon def init parenthesis self colon. Inside the init method, we will set up an attribute called blocks group to store all the individual blocks within this obstacle. This attribute will be a group. It will help us draw all the blocks at once. Self.blocksGroup is equal to pygame.sprite.group. Now we will iterate through all the cells in the grid and create a new block only when we find the value 1 in a cell. Let's do it. For row in range parenthesis len grid colon. For column in range parenthesis len parenthesis grid bracket 0 colon. With these two lines of code, we check every cell of the grid. The first line of code iterates through each row in the grid. The row will take values from 0 to len grid -1, effectively representing each row in the grid. This line of code iterates through each column within the current row being processed. Column will take values from 0 to len grid bracket 0 -1, representing each column in the current row. This expression returns the number of columns in the grid. Since the grid is a list of lists, grid 0 refers to the first row in the grid, and the length of that row gives us the number of columns in that row. These two lines of code help us go through every square in our grid by looking at rows and columns. We want to see what's inside each square and decide if we should create a block there or not. Now we will see if we find the number 1 in each cell. if grid brackets row brackets column equals 1 colon. If we find 1, we need to create a new block. Block is equal to block. But the block class needs an x and y value to determine where to draw it. So let's enter pos x and pos y here. Since we are using a grid, we can easily calculate the coordinates of each cell in the grid. Pos x is equal to column times 3 and pos y is equal to row times 3. This line calculates the x-coordinate of the block based on the column number in the grid. Since each block is 3 pixels wide, we multiply the column number by 3 to determine the correct x-coordinate for that block. This ensures that each block is horizontally aligned with the others in the grid. Similarly, this line calculates the x-coordinate of the block based on the row number in the grid. Again, since each block is 3 pixels tall, we multiply the row number by 3 to determine the correct y-coordinate for that block. This ensures that each block is vertically aligned with the others in the grid. Now we can add the block we just created in the blocks group. self.blocksgroup.add parenthesis block. Perfect. Let's try this class to see if it works. So let's go to the main.py file and create an obstacle. First, let's import the obstacle class. From obstacle, import obstacle. Now let's create an obstacle. Obstacle is equal to obstacle. Now in the game loop, let's draw all the blocks it contains. Obstacle.blocksgroup.draw parenthesis screen. Let's run the game now. You will notice that an obstacle has appeared at the top left corner of the screen. However, to make this class more versatile, we should have the option to place the object anywhere we want on the screen. Let's implement this feature. Back to the obstacle.py file. To make the obstacle class more versatile and allow us to place it anywhere on the screen, we will introduce some changes. First, let's modify the constructor of the obstacle class. The init method must accept two additional arguments, x and y, which represent the desired coordinates where the obstacle will be positioned. Here's how we can modify the constructor. Def init parenthesis self, x, y. Now, when we create an obstacle object, we can specify the x and y coordinates to control its placement on the screen. Next, within the constructor, we will adjust the calculations for the position x and position y variables of each block based on the provided x and y coordinates. This way, we can customize the obstacle's position. Pos x is equal to x plus column times 3 and pos y is equal to y plus row times 3. With these changes, you can easily create obstacles at different locations within your game world. Let's test it out. In the main.py file, let's position the obstacle at position 100, 100. We modify this line of code like this, 100, 100 here. Let's run the game. Cool, as you can see, the obstacle has moved. Our obstacle class is ready. Our game will use 4 obstacles, so we can create them now and place them to the desired position. But we won't do it now. To improve code organization and make it easier to manage in the future, we will create a game class to hold all the game elements as well as various methods. The game class will serve as a container for all the elements of our game, such as the spaceship, the obstacles, the aliens, and the game state. It will also hold methods that manage the game's logic, such as updating the positions of the game object, checking for collisions, updating the score, etc. By centralizing all the game's functionality within this class, it will be easier to understand, maintain, and expand upon in the future. Additionally, it will also improve code readability and reduce the risk of bugs by keeping related code together in one place. Overall, creating a game class will greatly improve the organization and structure of our code base, making it easier to work with in the future. So let's create a new game class. We create a new file and we call it game.py. Now we type import pygame. Class game : def init parenthesis self, colon. The game class must create and hold a spaceship. So let's import the spaceship class we have created. From spaceship, import spaceship. Now let's create a spaceship group to hold the spaceship. Self.spaceship group is equal to pygame.sprite.group single. Now we need to add a spaceship object to it. Self.spaceship group.add parenthesis spaceship and again parenthesis. But in order to create a spaceship, we need to provide the screen width and screen height to the constructor. So let's add two attributes to the class to hold the screen width and screen height. So we type self.screenWidth is equal to screen width and self.screen height is equal to screen height. And here we have to type comma screen width comma screen height. Now we can create the spaceship by entering self.screenWidth comma self.screen height here. With this, our first version of the game class is ready. Let's test it out. Let's go back to the main file. Let's delete all the objects we had created manually before. Also, let's remove all the calls in the game loop. Now let's also remove all the imports we were using for these objects, then let's just import the game class. From game import game. Now let's create a game object. Game is equal to game parenthesis screen width comma screen height. The game class holds a spaceship group. Let's first update it and then draw it. In the game loop we type game.spaceshipgroup.update and then game.spaceshipgroup.draw parenthesis screen. If we run the game now, we can see the spaceship appears on the screen and we can move it as before. But even if I press the spacebar, the lasers do not appear. What is going on? The spaceship group contains a spaceship object that contains a lasers group with all the laser sprites. We have to draw this lasers group as well. Let's do it. Game.spaceshipgroup.sprite.lasersgroup.draw parenthesis screen. Let's give it another go. Now, when we run the code, you'll notice the spaceship and lasers appearing on the screen. Take a moment to appreciate how much more organized and user-friendly our code has become. It is essential to keep your code well structured. It not only makes your life easier, but also ensures your project stays manageable and maintainable. Now let's go back to the game class and add 4 obstacles to it. First of all, let's import the obstacle class and the grid from the obstacle file. From obstacle import obstacle and from obstacle import grid. Now let's create a method to create 4 obstacles for our game. Def create obstacles parenthesis self colon. Creating the obstacles is straightforward, but calculating their horizontal positions can be a bit tricky. We have 4 obstacles to arrange horizontally, and we want equal gaps between them. To achieve this, let's break it down step by step, starting with calculating the width of each obstacle. To find the width of the obstacle, we will multiply the number of columns the obstacle grid has by 3 pixels. Obstacle width is equal to length parenthesis grid bracket 0 times 3. Now we need to calculate the gap between the obstacles. It is easy. From the total screen width, we will subtract the width of the 4 obstacles and divide that by 5 because we have 5 gaps in total. Gap is equal to self.screenWidth minus parenthesis 4 times obstacle width, and let's put all of this inside another parenthesis here, divided by 5. That's it. Now let's create a list to hold all the obstacles. Obstacles is equal to brackets. Now let's create 4 obstacles in a for loop. For I in range parenthesis 4. First we have to calculate the offset x position of the obstacle. Offset x is equal to parenthesis I plus 1 times gap plus I times obstacle width. This line of code calculates the horizontal position of each obstacle by adding equal gaps between them, ensuring they are evenly spaced. Now we can create our obstacle. Obstacle is equal to obstacle parenthesis offset x comma self.screenHeight minus 100. We position it vertically 100 pixels from the bottom of the screen. Now we can add the obstacle in the obstacles list. Obstacles.append obstacle. And lastly, we can return that list. Return obstacles. Cool! We can now create an obstacles attribute to the game class to hold all the obstacle objects. Self.obstacles is equal to self.createObstacles. We are now ready. We can go back to the main screen and in the game loop we can draw the 4 obstacles. For obstacle in game.obstacles : each obstacle has a blocks group attribute that we can draw. Obstacle.blocksgroup.draw screen. If we run the game now, we can see 4 obstacles on the screen evenly distributed. Great! All the game elements are now created and controlled by the game class. Another step is now complete, and we have made significant progress. Now let's move on to step number 6, creating the aliens. Our game is designed to have 5 rows and 11 columns of aliens. All of the aliens move collectively, either to the left or to the right, occasionally firing lasers. When they reach the edge of the game window, they change their movement direction and shift slightly downward, progressively increasing the game's challenge. Let's implement this functionality. First of all, let's create a separate class called alien to display an alien sprite. We create a new file called alien.py. First of all, we import pygame. Import pygame. Again, this class will inherit from the sprite class. Class alien pygame.sprite.sprite : def init self : super .init . As we are inheriting from the sprite class, we need 2 attributes, an image attribute and a rect attribute. Self.image is equal to and self.rect is equal to. In our game, there are 3 different types of aliens. We will create a single alien class and we will change the type and the image of each one. So we will provide the class a type of alien and the class will load the appropriate image for its type. First, let's add an argument to the class, a type, type here, and self.type is equal to type. Now we have a type attribute. In the graphics folder, the alien images are named like this: alien 1, alien 2, alien 3 PNG. So we can easily load them like this. First, let's create a path variable to hold the path for each alien image. Path is equal to f quotes. We will use an f-string. Check out this video if you don't know how an f-string works. Now inside the quotes, graphics/alien _ curly brackets type.png. Inside the f-string, you have a string containing a file path. The curly brackets type within the string is a placeholder for a variable named type. The value of the type variable will be inserted into the string when the f-string is evaluated. So when this code is executed, the value of the type variable will be inserted into the file path, resulting in a specific file path based on the value of type. For example, if type is 1, it will create a path like this: graphics/alien1.png. This dynamic string formatting is a convenient way to generate file paths or strings based on the current values of variables. Now that we have the path of the image, we can load it. Self.image is equal to pygame.image.load path. Perfect. Now we need to get the rect of the image. Self.rect is equal to self.image.getRect. And we need to place that rect somewhere on the screen. We will enter the x and y coordinates as an argument to the class. So in the init method, we enter x and y here, and then in this line of code, let's position the top left corner of the rect at the x and y coordinates we provided the class. Top left is equal to x, y. The first version of our alien class is ready. Let's now go to the game class to create some aliens. First, let's import the alien class. From alien, import alien. Now let's create an aliens group attribute to the class that will hold all the aliens. Self.aliensGroup is equal to pygame.sprite.group. The next step is to create a new method in this class which will be named createAliens. So we type def createAliens parenthesis self colon. As we said before, we have 5 rows and 11 columns of aliens. It is like a grid of aliens. Let's create that grid. We will use 2 for loops. For row in range parenthesis 5 colon. For column in range parenthesis 11 colon. I hard-coded the values for the number of aliens, but you can use variables here to make the game more versatile. Now we have to create an alien for each cell of the aliens grid. Alien is equal to alien parenthesis. To create an alien object, we must provide the alien class with 3 essential values. First, we specify the type of alien we want to create, which determines its appearance. Additionally, we need to specify the desired x and y coordinates of the screen where we want the alien to appear. The type is easy. For now, let's just enter 1. Now we need to calculate the x and y coordinates for each alien. Let's create 2 variables for x and y. Since we are using a grid, we can calculate the position of each alien like this. X is equal to column times cell size and y is equal to row times cell size. For cell size, let's hard-code it to 55 pixels. We make each cell of the alien grid to be 55 by 55 pixels. This is a value that I found works okay. So now our alien construction can be completed. Alien is equal to alien parenthesis 1, x, y. Now let's add this alien in the aliens group. Self.aliensGroup.add parenthesis alien. We are ready. This nested for loop will create 55 aliens of type 1. Let's call this method in the constructor. Self.createAliens. Let's try it to see if it works. Let's go back to the main.py file. In the game loop, we just called the draw method of the aliens group attribute. Game.aliensGroup.draw parenthesis screen. If we run the game now, we can see all the aliens displayed on the screen. Cool, but there are a couple of things we have to fix. First, the aliens are drawn from the top left corner of the screen. We need to add an offset to the x and y coordinates of each one of them. Second, all the aliens look the same, but we want to have 3 types of aliens. Let's fix both problems. It is quite easy to do. Let's go back to the game class. The first problem is very easy to fix. We just have to add an offset of 75 pixels to the x coordinate of each alien and 110 pixels to the y coordinate. So we add plus 75 here and plus 110 here. Now let's fix the second problem. All the aliens are now created as type 1. We want to have the first row from the top to be of type 3, the second and third to be of type 2, and the last 2 of type 1. So before creating the alien, we just have to add an if statement. If row equals 0 colon alien type is equal to 3. Else if row in parenthesis 1, 2 colon alien type is equal to, else alien type is equal to 1. And now we have to modify the line that creates the alien like this. Instead of the hard-coded type 1 we have here, we have to enter the alien type variable. Let's go to the main file and run the game one more time. Beautiful. As you can see, all the aliens are now centered on the screen and we have all the 3 types of them. We are making great progress. We still have a lot of work to do with the aliens. First of all, the aliens must move. So let's modify the alien class again to make the aliens move. Let's add an update method to it. Back to the alien.py file. Def update parenthesis self, direction, colon. We want to control the direction of the alien. So let's add an argument to the alien class called direction. We are going to set the direction to 1 when the aliens move to the right and to -1 when the aliens move to the left. Now, all we have to do to move the aliens is to change the x attribute of the rect of each alien. Self.rect.x plus equals direction. We simply add or remove one pixel from its current position. If we want to move the aliens faster, we can multiply that by some value. Now let's go back to the game class and create a method that will move the aliens. Def move aliens parenthesis self colon. In this method, we need to invoke the update method of the alien class and provide it with a direction parameter. Let's create a new attribute named aliens direction for the direction of the aliens in the game class. Self.aliens direction is equal to 1. Now, let's pass this as an argument to the update method of the aliens group. Self.aliensGroup.update parenthesis self.aliens direction. Now let's test this code. Let's go to the main file and let's test it out. In the game loops, we have to call the moveAliens method. Game.moveAliens. If we run the game now, we can see the aliens move. But as you can see, we have a small problem. The aliens can move outside of the game window. We have to constrain the movement of the aliens inside the game window. We will solve this issue as follows. We will check every alien in the grid. If any of the aliens has moved outside of the game window, we will change the direction of all the aliens in the grid. Let's do it. Again, in the game class, in the moveAliens method, we add the following. First, we have to get all the alien sprites in the list. We can do this with the following line. Alien sprites is equal to self.aliensGroup.sprites. Then we have to check every alien in the list. If it has moved outside of the game window, we change the aliens direction attribute. For alien in alien sprites, colon. If alien.rect.write greater than or equal to self.screenWidth, colon. Self.aliens direction is equal to -1. Else if alien.rect.left less than or equal to 0, colon, self.aliens direction is equal to 1. That's it. Let's go back to the main file and run the game one more time. Now, if our aliens reach the end of the game window, they change their direction. Beautiful. Our aliens move. But in the original Space Invaders game, when the aliens reach the end of the screen, they also move down. Let's implement this feature. We have to go back to the game class. Let's add another method to it. Let's call this method alienMoveDown. Def alienMoveDown parenthesis self colon. This method will take the distance to move the aliens down as an argument, so we type, distance here. Now, if there are visible aliens on the screen, if self.aliensGroup, then we have to get every alien sprite and move it down by that distance. For alien in self.aliensGroup.sprites parenthesis, alien.rect.y plus equals distance. That's it. Our method is ready. Now we have to call this method every time the aliens hit the end of the screen. So in the moveAliens method, we add this line of code. Self.alienMoveDown parenthesis to here and here to move the aliens 2 pixels down. Let's go back to the main file and test our game one more time. Perfect. Our aliens move. And when they hit the end of the game window, they move 2 pixels down. Cool. Now, the only thing that remains before moving on to the next step is to add the ability to the aliens to fire lasers. Let's do it. Back to the game class. Let's add another attribute to our game class. It will be a group to hold all the alien lasers. Self.alienLasersGroup is equal to pygame.sprite.group. Now let's create a method that will select a random alien and shoot a laser from it. Since we need to use a random number, we will import the random module, random here. Now let's create the method. Def alien shoot laser parenthesis self colon. First, we need to check if there are any visible aliens on the screen. If self.aliensGroup.sprites parenthesis colon. Now we need to select a random alien from all the visible aliens. A random alien is equal to random.choice parenthesis self.aliensGroup.sprites parentheses. We use the choice function which selects a random item from a list. Now we need to create a laser for that alien. We will shoot the laser from the center of the alien sprite. So we type laser sprite is equal to laser parentheses random alien dot rect dot center comma -6 comma self dot screen height. We give it a -6 value because we want the laser beam to move downwards. Also, don't forget to import the laser class. From laser, import laser. The last step is to add the laser to the alien lasers group. Self.alienlasersgroup.add parentheses laser sprite. Cool, the code for adding the ability to the aliens to shoot lasers is ready. Let's go back to the main file to test it out. First of all, we have to call the method alienShootLaser inside the game loop. Game.alienShootLaser parentheses. Next, we need to update the position of the laser's beam. Game.alienLasersGroup.update. Lastly, we have to draw all the lasers on the screen. Let's do it. Game.alienLasersGroup.draw screen. Let's run the game. As you can see, our aliens can shoot lasers, but we have created a laser rain. We have to make our aliens shoot lasers at a slower rate, for example, every 300 milliseconds. To achieve this, we are going to create a timer event using the Pygame library. First, let's create a custom event for our game and give it a name. ShootLaser is equal to pygame.userEvent. This line of code creates a variable ShootLaser and assigns it the value of pygame.userEvent. UserEvent is a special event type in Pygame that can be used to create custom events. In this case, it is used to create an event that will be triggered every time we need to shoot a laser from the aliens. Now, let's tell Pygame when to trigger this custom event. We want to trigger it every 300 milliseconds. To do this, we will use the setTimer function from the pygame.time module. Pygame.time.setTimer parentheses shootLaser, 300. This function creates a timer that will trigger the ShootLaser event every 300 milliseconds. The first argument is the event that needs to be triggered, and the second argument is the interval in milliseconds. In this way, we are ensuring that the game is shooting lasers from the aliens every 300 milliseconds and not 60 times per second, avoiding the problem of the laser rain on the player. Now in the game loop, as we said before, we check for any events that happened since the last time the game loop was executed. Let's add a check for our custom event. This is very simple. If event.type equals shootLaser, game.alienShootLaser. Also, don't forget to remove the second call of the alienShootLaser from here. That's it. Let's test the game one more time. Perfect. The aliens move and they shoot lasers every 300 milliseconds. That's more playable. With that, we just finished step number 6. The basic game logic is almost ready. We just need collisions and to code the mystery ship. Before working on the collisions, let's first work on the mystery ship, the last game element. The mystery ship is another alien ship that periodically appears at the top of the screen and moves horizontally, either to the left or to the right. Unlike the regular alien ships, this unique alien ship doesn't shoot lasers. However, players have the opportunity to earn extra points by hitting it. So let's enhance our game by adding this intriguing feature to it. Let's go back to the alien file and add a new class into it. Let's create a mystery ship class. Again, the mystery ship is going to be a child of the sprite class, so we type class mystery ship parentheses pygame.sprite.sprite def init parentheses self super parentheses dot init parentheses. Now we need an image and a rect attribute. Self.image is equal to and self.rect is equal to. The image attribute is easy. We just have to load an image. Pygame.image.load parentheses quotes graphics/mystery.png. Now the rect. Let's place the mystery ship image 40 pixels down from the top of the screen. The mystery ship can spawn either from the left or from the right side of the screen, so its x coordinate will be a variable. Let's call it x. Self.rect is equal to self.image.getRect parentheses top left is equal to parentheses again x, 40. Now for the x we need to select a random starting point, either the left or the right edge of the screen. Since we need to select a random value, let's import the random module, random here. Now let's select a random starting point. X is equal to random.choice parentheses and brackets. As we said before, the choice function returns a random element from a list. So let's enter two elements here, the x position of the top left corner of the mystery ship if it spawns at the left, and the top left corner of it if it spawns at the right. So we enter 0, screen width minus the mystery ship image width. So self.image.getWidth. But the class mystery ship does not know the width of the screen. We have to pass this information as an argument, so we type screen width here. And we can assign it to a screen width attribute. Self.screenWidth is equal to screen width. And here we add self.to access the screen width attribute. That's it. One last thing we have to do is to make the mystery ship move. So let's create an update method. Def update parentheses self : To move the mystery ship, we need to move its x position at every frame. So self.rect.x plus equals self.speed. But we don't have a speed attribute. Now the speed of the spaceship will be positive if it spawns at the left edge of the screen and negative if it spawns at the right edge of the screen. So let's add the speed attribute to the init method. If x equals 0, self.speed equals 3, else, self.speed is equal to -3. Perfect. One last thing we have to do before testing our code is to destroy the mystery ship object if it moves outside of the game window. So inside the update method we have to add this check. If self.rect.right greater than self.screenWidth, self.kill. Elif self.rect.left less than 0, self.kill. Now let's go to the game class. First of all, let's import the mystery ship class. From alien, import mystery ship. Now let's create a group to contain this sprite in the init method. Self.mysteryShipGroup is equal to pygame.sprite.groupSingle. Now let's think about when we want a mystery ship to be created. We don't want to create it when the game starts, but at random points in the game. So let's create a createMysteryShip method in the game class and call this method from time to time in our main game loop. Def createMysteryShip parentheses self : Now all we have to do is to create a mystery ship object and add it to the mystery ship group. Self.mysteryShipGroup.add parentheses mystery ship parentheses self.screenWidth. Cool! Now let's go to the main file. To create a mystery ship at random points in the game, we will create a timer just like we did before with the alien lasers. But this time, the interval of this timer won't be constant. We will choose a random value. So, since we are going to use a random value, we need the random module. So we have to import it here, random. Now let's create a timer. Mystery ship is equal to pygame.userEvent plus 1. Now we need to set the interval in milliseconds. Pygame.time.setTimer parentheses mystery ship, random.randint parentheses 4000, 8000. I enter small random numbers to test it out. Now in the game loop, all we have to do is to check if the mystery ship event has occurred. If event.type equals mystery ship, colon. Now we have to create the mystery ship. Game.create mystery ship. And then set the interval of the timer to a new random value. Pygame.time.setTimer, parenthesis, mystery ship, random.randint 4000, 8000. Lastly, we have to call the update and draw methods of the mystery ship group in the game loop. Game.mysteryshipGroup.update here and game.mysteryshipGroup.draw parenthesis screen here. Let's test it out. We have to wait for a few seconds for a mystery ship to appear. Perfect. As you can see, a mystery ship has appeared and it looks so cool. With some luck, we can see the mystery ship spawn from both the sides of the screen. That's it. Cool, our game elements are ready. Another step is now complete. We are now ready to move on to step number 8. Let's work on the collisions. You may think that collisions will be hard to implement, but thanks to the sprite class, collisions are actually an easy step in our game development. There is this very useful method, sprite collide. This method checks if a specific sprite collides with any of the sprites of a group. Not only that, it allows you to destroy the sprite it collides with automatically. Let's use it at once to better understand how it works. Let's go to the game class and create a new method that we are going to call check for collisions. Def check for collisions parenthesis self colon. First, let's check if any of the spaceship lasers fired collide with any of the alien sprites. As we said, the first argument of the sprite collide function is a sprite, so we need to get the spaceship laser sprites. First of all, let's check if there are any visible spaceship lasers on the screen. If self.spaceshipgroup.sprite.lasersgroup colon. If that's the case, for every laser visible, for laser sprite in self.spaceshipgroup.sprite.lasersgroup colon. Check if it collides with any of the sprites of the alien group. Pygame.sprite.spriteCollide parenthesis laser sprite, self.aliensgroup, comma. Do we need to destroy the item that the laser collides with? Yes, so we enter true as the third argument of this function. Do we also need to destroy the laser sprite when it hits an alien? Yes. Luckily for us, this method returns a list containing all the sprites in a group that intersect with another sprite, so we can use this information. We add an if here and a colon here. So, if the return list is not empty, it means we had a collision, so we have to destroy the laser sprite as well. Lasersprite.kill, parenthesis. Let's test it out. Let's go back to the main file. First, we have to call the method in the game loop, so we type game.checkforcollisions, parenthesis, here. If we run the game one more time, we can see that now, each time a laser layer hits an alien, it destroys it. Perfect, our collisions with the aliens work. Let's do the same thing with the mystery ship as well. In the game class, here, we just have to add another if statement. If our laser hits the mystery ship. We copy these two lines of code and here we just change this group to the mystery ship group. That's it. Let's test it out again. I will play the game for a few seconds until I am able to hit the mystery ship. Beautiful. The laser can now hit both the aliens and the mystery ship. Let's move on to the obstacles. The spaceship laser must be able to damage the obstacles. As we said before, each obstacle is just a bunch of small blocks. When a laser beam hits an obstacle, we have to destroy the block it hits. Let's go to the game class to work on this behavior. We need another if statement to check if any of the blocks of the obstacle is hit. But we have 4 obstacles, so we need to check each obstacle one after another. So we will use a for loop. For obstacle in self.obstacles:. Now for each obstacle, if the laser collides with any of the blocks of the obstacle, remove both the block and the laser. If pygame.sprite.spriteCollide laser sprite, obstacle.blocksGroup, true laser sprite.kill . Impressive, huh? With just 3 lines of code, we implemented collision detection between the laser and the obstacles. That's the power of the sprite class. Let's test it out one more time. Back to the main.py file. As you can see now, if I shoot at the obstacles receive damage. Perfect, the spaceship laser is now complete. Let's do the same thing with the lasers the aliens shoot. Back to the game class. Let's add a comment here. Alien lasers. Again, we need to check if there are any visible alien lasers. If self.alienLasersGroup:. Now we need to get each of the lasers from the group. For laser sprite in self.alienLasersGroup:. Again, we have to check if the alien laser collides with the spaceship, but this time we don't want to kill the spaceship object. The player will have 3 lives. If pygame.sprite.spriteCollide laser sprite, self.spaceshipGroup, false, . Now we need to destroy the laser object and print something to the console to know that we got a hit. Laser sprite.kill and print quotes spaceship hit. We also need to make the alien lasers hit the obstacles. We just have to copy this block of code from here and paste it here. Okay, let's test the game one more time. As you can see, now the obstacles get damaged each time they get hit, either from an alien or from a spaceship laser. Also, if the spaceship is hit by an alien laser, it prints the message spaceship hit to the console. Beautiful, our collisions work. Before we move on to the next step, we need to check for another collision. What happens if an alien sprite collides with the obstacles? In that case, the obstacle must receive damage, just like it was hit by a laser. Also, what happens if the spaceship is hit by an alien? Also, it must receive damage. Let's implement this behavior in the game class. Again, in the check for collisions method, we add the following code. If there are aliens on the screen, if self.aliensGroup:. Let's get each alien sprite from the group. For alien in self.aliensGroup:. Now let's check for collisions between each alien with the obstacles. We need to check all the obstacles. For obstacle in self.obstacles:. Now we need to check for collisions between the alien sprite and the blocks of the obstacle. pygame.sprite.spriteCollide alien, obstacle.blocksGroup, true. That's it. We don't need to kill the alien if it hits an obstacle, just to kill the obstacle block, and that happens automatically by the function. Now the last thing we have to do is to check if the alien sprite hit the spaceship sprite. In that case, we don't want to kill any sprite, just print a message for now if that happens. If pygame.sprite.spriteCollide alien, self.spaceshipGroup, false, print spaceship hit. Great, our collision code is ready. Let's test our game one more time. I will increase the alien speed to check for collisions without having to wait for a long time. Let's see. As you can see, when the aliens hit the obstacles are wiped out, block by block. Perfect. Also, when the aliens hit our spaceship, we get a message to the console that the spaceship got hit by an alien. Very cool. Believe it or not, with this, our game mechanics are ready. Great job on reaching this far to the tutorial. Another step is now complete. Now, let's focus on the next step, adding a game over condition to our game. The game will end when the player's spaceship gets hit 3 times by an alien laser or by direct contact with an alien. So the player must have 3 lives. Let's go to the game class and add a lives attribute to it. Before doing that, let's change the speed of the aliens back to 1. Now let's go to the init method and type self.lives is equal to 3. Now we have to decrease the value of this attribute each time the spaceship is hit by a laser. So in the method check for collisions we add the following. We check if the spaceship is hit by an alien laser here. So we add the following line, self.lives minus equals 1. Now we have to check the number of lives remaining for the player. If this number is 0, then we have to end the game. If self.lives equals 0, colon. In that case, let's call a game over method, self.gameover. Now let's create this method, def gameover parenthesis self colon. For now, let's only print a game over message, print parenthesis quotes game over. We also need to call this method when the spaceship collides with an alien sprite. So, in the check for collisions method in this line of the code, we check if the spaceship collides with an alien sprite. If that's the case, we have to end the game, self.gameover. Let's go to the main file and test the game. If we run the game and play for a few seconds and get hit 3 times by a laser, or we get hit by an alien, the game over message appears to the console. But the game does not stop. We have to implement this. Let's go back to the game class and add a new attribute to our game. Self.run is equal to true. This attribute will have the value true if the game runs and false if the game has stopped. So when the game ends, we need to give this attribute the value false. So let's go to the gameover method and make that change. Self.run is equal to false. Now let's go to the main file and use this attribute to stop the game from running when the game is over. In the game loop, when the game has stopped, we have to stop updating the positions of the game objects. We need the game to freeze, so we add the following if statement, if game.run colon. If the game runs, we need to update the positions of all the objects. So we intend all these methods that update the position of the objects to belong to the if statement. Also, we need to stop creating new lasers from the aliens and the mystery ship when the game has ended. So up here, we have to add this condition, end game.run, here and here. Now we can test the game one more time. When we get 3 hits, the game ends and all the elements of the game freeze. Perfect. But now we can't restart the game. Let's make the game restart when we press the spacebar one more time. In the game loop, at first we check for events. Let's check if the user has pressed the spacebar and the game is stopped. Keys is equal to pygame.key.getPressed parenthesis. If keys brackets pygame.keyspace and game.run equals false colon. Now we need to restart the game but from its initial state. So let's call a reset method, game.reset parenthesis. Of course, this method does not exist yet. We have to create it. Let's go to the game class to create this method. Def reset parenthesis self colon. At first, we have to set the run attribute to true to restart the game. Self.run is equal to true. Then we have to set the lives attribute back to 3. Self.lives equals 3. Next, we need to reset all the game elements to their original state. When we reset the game, we have to move the spaceship sprite to the center of the screen and also delete all of its lasers. Let's create a reset method to the spaceship class. In the spaceship file, let's create the method def reset parenthesis self colon. Now all we have to do is to center the spaceship sprite to the screen with this line of code. Self.rect is equal to self.image.getRect parentheses. Mid-bottom is equal to parentheses self.screenWidth divided by 2, comma self.screenHeight. And then we delete all the lasers the spaceship has fired and are visible. Self.lasersGroup.empty parentheses. Great! Now let's go back to the reset method of the game class. Let's call the reset method of the spaceship self.spaceshipGroup.sprite.reset. Okay, the spaceship is now reset. Now let's reset the aliens. That's easy. We first have to delete all the alien sprites from the aliens group and the alien lasers from their group. Self.aliensGroup.empty parentheses and then self.alienlasersGroup.empty. Next we need to recreate them. We have a method for this, self.createAliens parentheses. We also have to delete the mystery ship sprite if it is visible. Self.mysteryshipGroup.empty parentheses. The last step is to recreate the obstacles. We also have a method for this. Self.obstacles is equal to self.createObstacles. Perfect. Let's test the game one more time. Okay, if we play the game for a few seconds, we can see that the game works as expected. When we get hit 3 times, the game ends, it freezes, and then if we press the spacebar one more time, it restarts. Beautiful. The problem is that the player does not know how many lives it has, or the game state. Let's create a user interface like this one to display the lives, the level, the score, and the high score to the user. When the game ends, the game will display a game over message. First of all, let's change the dimension of the game window to be 800 by 800. This way we will have more space to display the user interface. So in the main file, let's create a new variable called offset and set it to 50 pixels. When we create the game window in this line of code, let's add 50 pixels to its width and 100 pixels to its height. We add plus offset here and plus 2 times offset here. Now let's create a yellow rounded rectangle to act as a frame around our game window. First, let's create a tuple for the yellow color. Yellow is equal to parentheses 243, 216, 63. Now let's create a rounded rectangle with no fill to act as a frame for our game. In the game loop, after we clear the background, we use the following pygame function. Pygame.draw.rect parentheses screen, comma, yellow, comma, parentheses 10, 10, 780, 780, 2, 0, 60, 60, 60, 60. This line of code draws a rectangle on the screen using pygame, specifying the following parameters: screen as the drawing surface, yellow as the color, and these values as the rectangle's position and size. 2 as the line thickness, 0 because we need no fill to it, and 60 as the corner radius for rounded corners. If we run the game now, we can see the frame appears on the screen. Let's also add a line at the bottom of the screen to act as a border for the lives and the level message. Pygame.draw.line parentheses screen, comma, yellow, comma, parentheses 25, 730, comma, parentheses 775, 730, 3. This line of code in Pygame draws a yellow horizontal line on the screen with a thickness of 3 pixels, starting at coordinates 25, 730 and ending at coordinates 775, 730. If we run the game one more time, we can see that the line appears. Before adding some UI elements, let's fix an issue with our code so far. The game elements, the spaceship, the aliens, the obstacles, and so on, are drawn with the origin being at 0, 0. Now the origin point has moved to the right by 25 pixels, which is offset over 2 pixels. We need to fix the positioning of all the game objects. Let's start with the spaceship. Let's go to the spaceship class. We need to pass the offset as an argument to the class, so we enter offset here. We also create an offset attribute. Self.offset is equal to offset. We also need to make the following changes. In the init method, where we set the original position of the rect, we change this part like this. Screen width plus self.offset inside the parentheses divided by 2. We also need to change the constraint position method like this. We need self.offset here and here. The last change is in the reset method. Again, we have to add offset here plus self.offset in the parentheses divided by 2. Okay, the spaceship class is ready. Let's go back to the game class and make some changes there as well. The game class must get the offset as an argument. Let's enter it in the init method. Offset here. Also, we need to create an offset attribute. Self.offset is equal to offset. Now we have to pass this offset when we create the spaceship object here. Self.offset. Now let's go to the main file. When we create the game object, we have to give its constructor the offset as an argument. So here we just enter offset. If we run the game now, we can see that our spaceship is now centered at the game window and it cannot move outside of it. Good. Let's also make some changes so the obstacles are also drawn correctly. In the game class, where we create the obstacles, we just have to make a tiny change. Here, in the create obstacles method, we calculate the gap between the obstacles. We need to add the offset because the screen has now increased its size. Plus self.offset here. Let's go back to the main file and run the game again. Perfect. The obstacles are now centered. Let's now work with the aliens. I know it is getting tedious, but hang on there. We are almost ready. In the create aliens method, let's add the offset here. Plus self.offset over 2. Now we also need to modify the move aliens method. Here, if alien.rectRight greater than or equal to self.screenWidth plus self.offset over 2. And here, less than or equal to self.offset over 2. The last thing we have to do is to also change the mystery object spawn points and the points at which we kill it. Let's find the call to the mystery ship constructor and add an offset parameter. Self.offset here. Now let's go to the alien file. The mystery ship class will get the offset as an argument, so we type offset here. Next, let's create an offset attribute to it. Self.offset is equal to offset. Now in this line we set the spawn points of the object. Let's modify this line like this to include the offset in our calculations. Self.offset over 2 here and plus self.offset here. We also have to change the next line. If x equals self.offset over 2 colon. Lastly, we have to modify the update method as well. We have to add plus self.offset over 2 here and self.offset over 2 here. That's it. We are now ready to test our game one more time in the main file. Perfect. The game works and all the elements are aligned properly in the game window. I know this procedure was boring, but now we are ready to move on to a more interesting thing. Let's now add a message on the screen to display either a level or a game over message. We won't implement levels today, but we will display a level 1 message if the game runs and the message game over if the game has ended. In Pygame, to create and display some text, we need to follow 3 steps. First, we need to create a font, then a surface with the text we want to display, and then we can display that surface using the blit method of the display surface object. First, let's draw a level title. So, outside of the game loop, below the pygame.init call, let's create a font. Font is equal to pygame.font.font, parenthesis, with a capital F here. And we have to give it a font family and a size. For the font family, I will enter quotes font / monogram.ttf. This is the font we are going to use in this game, and it is located in the font folder in our game folder. For the size of the font, I give it the value 40. The first step is done. Now we have to create a surface for the text we want to draw. To do this, we use the render method from our font object. Level surface is equal to font.render. We pass in the string we want to display, quotes level 01. We set the anti-alias argument to false because we are working with pixel art graphics, and finally we set the color of the font. I am going to set it to yellow. Now we can call the blit method to display the level surface on the display surface, which we have named screen. Blit means block image transfer. Most of the time in Pygame we are going to be blitting images to the display surface. We will call the blit method inside the game loop. We have to pass in the surface that we want to display and the location on the screen. So we type screen.blit parenthesis level surface and the position we want it to be in a tuple. Let's say parenthesis 570, 740, 50, 50. Let's run the game. Cool. The level 1 title appeared in its position, but we want to display this text when the game runs and the message game over when the game ends. Let's do it. Let's create another surface for the game over message. Outside of the game loop, let's create that surface. Game over surface is equal to font.render, parenthesis, quotes, game over, comma, false, comma, yellow. Now in the game loop, we have to check if the game runs. If it runs, we will display the level surface, else the game over surface. Let's add this check. If game.run, colon. Now we intend this line of code to belong to the if statement like this, and then display the game over message in any other case. Else, colon, screen.blit, parenthesis, game over surface, comma, parenthesis, 570, 740, 50, 50. Cool, let's test it out. Okay, if we run the game for a few seconds, we can see that when the game ends, a game over message appears. Perfect. Next, we will tackle something important, showing how many lives the player has left on the screen. To do this, we will use the spaceship image and show it multiple times, representing the player's remaining lives. The algorithm for this is very simple. We just have to display the spaceship image on the screen with the blit function as many times as the player's lives. So we're going to use a for loop. For live in range, parenthesis, game.lives, colon, screen.blit, and we need a surface and a position. Now for the spaceship image, there is no need to load it again. We have already loaded it earlier. We can simply access it from where it is stored. It is stored inside the spaceship object. game.spaceshipgroup.sprite.image. Now we need to position each image on the screen. We need an X and a Y value. The Y value is very easy. Let's place it 745 pixels from the top of the screen. Parenthesis X, 745. The X depends. If it is the first image to be displayed, it must be 50 pixels. If it is the second, it must be 100 pixels. And if it is the third, it must be 150 pixels. We can express this in code like this. Let's create a variable. X is equal to 50. We use this variable in the blit method and then we increase it by 50 pixels. X plus equals 50. That's it. Let's run the game one more time. Perfect. 3 spaceships are displayed to the bottom left side of the screen, representing the lives our player currently has. If we get hit, the number of spaceships displayed decreases by 1. Another step is now complete. Well done reaching this point to the tutorial. We have just 3 more steps to do. The next step is to add scoring to the game and display it on the screen. In our simplified version of Space Invaders, the player will earn points each time it hits an alien or the mystery ship. The player gets 100 points when he hits an alien of type 1, 200 points when he hits an alien of type 2, and 300 points when he hits an alien of type 3. Also, he earns 500 points when he hits the mystery ship. To implement this scoring system, we will need to add a score attribute to our game class. So in our game class, in the init method, we add self.score is equal to 0. Now let's go to the check for collisions method. We need to update the score every time the spaceship laser hits an alien, but we need to award the player with points according to the type of the alien. How do we know which type of alien we hit? With the code we have written so far, we don't know this information. All we check is if the spaceship laser has hit any alien. We need to store the aliens hit in a variable and check them for their type. So we will alter this block of code like this. Aliens hit is equal to pygame.sprite.spriteCollide. This line remains the same. Here we get a list with all the aliens hit. We also have to remove the colon from here. If aliens hit, colon. If the list is not empty, let's check all the aliens. For alien in aliens hit, colon. The alien class has a type attribute, so we can use that to calculate the score. Self.score plus equals alien type times 100. And then lasersprite.kill. Give me a second to make this block of code more readable. Okay. Also, if we hit the mystery ship, we need to award the player with 500 points. Self.score plus equals 500. That's the scoring system. Before moving on, let's not forget to reset the score back to 0 when the game ends. So in the reset method, let's set the score back to 0. Self.score is equal to 0. Okay, now let's go to the main file and create a score surface to display it on the screen. First, let's create the text score. Just like before, we type score text surface is equal to font.render parentheses pot score, comma, false, comma, yellow. And in the game loop, we display that static surface with the following line. Screen.blit parentheses score text surface, comma, parentheses again, 50, 15, 50, 50. Let's do a quick test to see if that works okay. Perfect, the text score has appeared. Now let's print the score itself. This time, since the score is not static but changes all the time, we have to create the surface inside the game loop. So, down here, we type score surface is equal to font.render parentheses string parentheses game.score, comma, false, comma, yellow. And now all we have to do is to blit this surface at a specific position. Screen.blit parentheses score surface, comma, parentheses 50, 40, 50, 50. If we run the game again, you will notice the score displayed just below the text score. As we hit aliens, the score increases, but it would look neater if we added leading zeros to it. This means that instead of just 100, we could have 0, 0, 100, or making the score more visually appealing. In Python, this is very easy to achieve. We need just one line of code. Let's create a new variable called formatted score. Formatted score is equal to str parentheses game.score.zfill parentheses 5. The code converts the game score to a string and pads it with leading zeros to ensure it is displayed as a 5-digit number. Cool. Now let's pass that string here instead of the game score string. Perfect. Let's run the game one more time. Amazing. The score is now displayed with leading zeros and it looks so cool. Another step is now complete. That was easy, wasn't it? But as you can see, we have a small issue. The mystery ship appears at the top of the screen below the score text. Let's fix it. Let's go to the alien.py file and in the mystery class, let's change its X position to 90 pixels from the top. Now, back to the main.py file to test it one more time. Perfect. The mystery ship now appears below the text score. Let's move on to the next step. Let's add a high score to the game. Again, let's go to the game class and add a new high score attribute to it. Self.highscore is equal to 0. Whenever we increase the score of the player, we need to check if it is a new high score. If it is, we need to copy the score value to the high score value. Let's create a method for this. Def check for high score, parenthesis, self, colon. If self.score greater than self.highscore, colon. Self.highscore is equal to self.score. Now let's call this method 2 times, when the spaceship laser hits an alien here. And here, when we hit a mystery ship. Perfect. Let's go back to the main file and display the high score on the screen. First, let's create the text high score. Just like before, we type high score text surface is equal to font.render, parenthesis, quotes, high score, comma, false, comma, yellow. And in the game loop, we display that static text with the following line. Screen.bleed, parenthesis, high score text surface, comma, parenthesis, 550, 15, 50, 50. Let's do a quick test to see if that works okay. Perfect. The text high score has appeared. Now let's print the high score value. Again, the high score is not static, but changes all the time. So we have to create the surface inside the game loop. So down here we type formatted high score is equal to str parenthesis game.highscore.zfill parenthesis 5, and then high score surface is equal to font.render parenthesis formatted high score, comma, false, comma, yellow. And now all we have to do is to bleed this surface at a specific position. Screen.bleed parenthesis high score surface, comma, parenthesis 625, 40, 50, 50. If we run the game again, you will notice the high score displayed just below the text high score. Perfect. Every time we hit a new record, the high score value changes. There is one problem though with our code. If we close the game, the high score is not saved. Let's also implement that. Let's save the high score to an external text file and load it at game start. Let's go to the game class. Inside the check for high score method, we check for high score. When that happens, we can save that high score to a file. We need just 2 lines of code. With open parenthesis, quotes highscore.txt, comma, quotes w, as file, colon. With this line of code, we create a new text file with the name highscore.txt if it does not already exist. Now we have to write the high score in it. File.write, parenthesis, str, parenthesis, self.highscore. That's it. Now we have to load this value when the game starts at the high score attribute. Let's create a new method that will load the saved high score from the file. Def load high score, parenthesis, self, colon, try, colon, with open, parenthesis, quotes, highscore.txt, comma, quotes r as file, colon, self.highscore is equal to int, parenthesis, file.read. We open the file and set the value we read to the highscore attribute. If there is no file named highscore.txt in the game folder, we set the highscore to 0, except file not found error : self.highscore is equal to 0. Okay, now that our method is ready, let's call it when the game starts in the init method of the game class, self.loadHighscore. Cool! Now if we run the game one more time, we can see that the highscore is still 0, since there is no highscore.txt file created yet. If we achieve a highscore, close the game and start it one more time, we can now see that the previous highscore value appears. How cool is that? Perfect! One more step is now complete. Let's complete our game by adding sounds to it. Sounds are important to a game as they provide feedback, create atmosphere, evoke emotions, and contribute to the identity of the game. Due to copyright reasons, I won't be using the original Space Invaders soundtrack for this game. Instead, I'll be using a theme created by my friend Spiros specifically for this video. The sound files are included in the GitHub repository of the game. You can find more amazing music by Spiros in a link provided in the video description. Now, in my game folder, I have created a new folder named Sounds and placed 3 sound files in it. One is named music.og, which contains the background music for our game, and the other 2 are laser.og and explosion.og. The first one is played when we shoot a laser with a spaceship, and the other one when we hit an alien. Of course, you can add many more sound effects to your version of the game. This is just a quick demonstration of how things work. Pygame supports various sound file formats, including MP3, but due to some known issues with MP3 support, I opted to use the OGG format instead. First, we need to start playing the background music when the game starts and ensure that the music loops continuously as long as the player is actively playing the game. We can do this either in the main file or in the game class. Let's implement it in the game class. First, we have to load the music. In the init method of the game class, we add this line of code: pygame.mixer.music.load. And now we have to add the file we want to load in quotes: sounds/music.og. The next step is to play the music. We have to use this line of code: pygame.mixer.music.play (-1). This line of code plays the background music using the pygame.mixer.music module, with the argument -1 indicating that the music should loop indefinitely. Let's test it. Perfect. We can hear the music of the game. Now, all we have to do is to add sounds for shooting a laser and for hitting an alien. We will add the laser sound to the spaceship class. We open the spaceship.py file and we add one more attribute in the init method: self.lasersound is equal to. Now we have to load the sound: pygame.mixer.sound (parentheses). And now we have to enter the file name in quotes: sounds/laser.og. Perfect, the sound is now loaded. We can play it. All we have to do now is to call the play method of the loaded sound. We have to play the sound when the spaceship shoots a laser. So inside the getUserInput method, after creating a new laser beam, we can add the following: self.lasersound.play. It is that easy. We have to do the same thing for the explosion sound, but we are going to load the sound in the game class because that's where we check for collisions. So, back in the game class, and let's create a new attribute: self.explosionSound is equal to pygame.mixer.sound (parentheses) quotes sounds/explosion.og. Now let's play that sound. We need to play the sound when a laser hits either an alien or the mystery ship. So we go to the check for collisions method of the game class. In this block of code, we check for collisions with the aliens. So here, before the for loop, we have to call the play method. self.explosionsound.play parentheses. Let's copy this line of code and add it to this block of code, where we check if we have hit the mystery object. Believe it or not, with that change, our game is ready. Let's test it out. Our game is ready. The music is playing, the sounds are playing, the score is updating, and in general the game works as expected, and it is very addictive. Amazing stuff! Congratulations on completing the Space Invaders tutorial. You have leveled up your game development skills and crafted an awesome game. Now, to celebrate your epic achievement, don't forget to check out our game developer t-shirts at our merch shop. They are not just stylish, they are a badge of honor for your journey into the world of game creation. To further your knowledge and continue learning, be sure to subscribe to our channel for more tutorials like this one. We will keep you updated with new and exciting projects that you can work on to enhance your skills. Thank you very much for watching this video. I'll see you next time.